Welcome to ScienceCover.com. In this session, we'll cover forces that act between objects. The aims are to cover contact and non-contact forces, and then to investigate reaction forces. Before we begin, pause the video and attempt the do no task. Let's check the answers. For 1A, the resultant force was 2 newtons to the right. For B, the resultant force was 2 newtons to the right. For C, we should have had 4.5 newtons diagonally down to the right. For D, we should have 3.6 newtons diagonally down to the right. Now let's look at forces that act between objects. We'll start by looking at contact and non-contact forces. The forces we see around us can be categorized into two forms, contact and non-contact. Contact forces are any force that is caused when one object makes physical contact with another. This wheel is in contact with the ground, therefore the friction it produces is a contact force. This sprinter's shoe is in contact with the ground, therefore the friction it produces is a contact force. This archer is in contact with the bow, therefore the stretching of the bow is a contact force. The air particles are striking this parachute. The air particles are in contact with the parachute, therefore air resistance is a contact force. This tug of war team is pulling on the rope. They are in contact with the rope, and therefore this push or pull would be a contact force. Non-contact forces are any force that can act over a distance. A magnet can attract iron over a distance, therefore magnetism is a non-contact force. Static charges can draw things together over a distance, therefore electrostatic forces are non-contact forces. And gravity will pull two masses together over a distance. This means that a gravitational force is a non-contact force. To describe how these non-contact forces work, in each of these cases we talk about a field around the object. So a magnet will have a magnetic field around it, an electrostatic force will have an electric field around it, and a gravitational body will have a gravitational field around it. Pause the video now and complete task 1. Let's check our answers to task 1. What is a contact force? This is a force that can only act when an object makes physical contact with another. What is a non-contact force? This is a force that can act at an object over a distance without the objects needing to be in contact. Place the forces into the correct columns in the table. So the contact forces were the push, the pull, friction, air resistance, and stretching. The non-contact forces were gravitational force, electrostatic force, magnetism, and weight. Let's now look at reaction forces. Isaac Newton came up with 3 laws of motion. His third law of motion said that any action will produce an equal and opposite reaction of the same type. Basically, this means that all forces produce an equal size force of the same type that acts in the opposite direction. Imagine this man pushes on the wall with a force of 5 newtons. According to Isaac Newton's third law, the wall will push back on the man with a force of 5 newtons. We know this is true because it is unlikely the wall will move. However, the man will move back. Almost all movement is based around the idea of reaction force. For instance, this swimmer will place their arm into the water and pull the water backward with a force of 10 newtons. The reaction force created by this is that the water will push the man forward with a force of 10 newtons. The force is always of the same type, so an electrostatic force will produce an electrostatic reaction force. A gravitational force will produce a gravitational reaction force, and a push will produce a push as its reaction force. The Sun has a gravitational force that pulls the Earth towards it. So the reaction force means that the Earth will pull the Sun with an equal size and strength. Pause the video now and complete task 2. Let's check our answers. Number 1. What is Newton's third law? Every action has an equal and opposite reaction of the same type. Number 2. Draw an arrow to show the size and direction of the reaction force and label the force in each diagram. So for part 1, the reaction force was to the right, it's the force of the air on the balloon. For number 2 is the force of the ground on the man, and the arrow should be pointed to the right. For number 3, we have a force up, and that is the force of the air on the blades. For number 4, the reaction force is to the right, and that is the force of the bullet on the gun. For number 5, the reaction force is to the right, and that is the water exerting a force on the swimmer. And for number 6, we have a force to the left, and that is the force of the nail on the hammer. Pause the video now and complete task 3, the summary task. Let's check our answers. What is the unit of force? It is the Newton. What is a contact force? It is a force that can act when one object is touching another object. What is a non-contact force? It is a force that can act over a distance without the two objects touching. Why does a force and its reaction force not cancel each other out? They are acting on different objects. For instance, force produced by A acts on B, but the force produced by B acts on A. Explain how all motion involves friction. Movement involves one object pushing off another object. This can be done by a wheel or a limb pushing the ground backwards. The reaction force will propel the object, person, or animal forwards. How can a non-contact force act on an object over a distance? Non-contact forces act within a field which is spread over the distance. A hammer hits a nail downwards with a force of 5 newtons. What is the reaction force? A nail hits the hammer upward with a force of 5 newtons. Explain how a rocket uses Newton's third law of motion. The ignited fuel is forced downwards. The reaction force will then push the rocket upwards.